All right, hey everybody. So we'll be waiting 5 minutes to see if more people are going to come. So you guys don't know, hey, we're going over Java basics. So I got this presentation directly from UT Austin, and if you guys are wondering, it's technically this is AP CSA. So yeah, technically what I'm going over is an AP course. So, hello, Rahul. Okay, I wonder how people came actually. All right, so I think we can start now because I just saw it jumped from 8 to 24 people. So let's start. So this is really what we're going over. So we're going to go do like a brief history of Java. You might solve a problem and discuss some coding issues. So the errors you might occur when you're coding and more details on syntax. So I'll probably look like our group will probably post all our presentations later on. But if you guys are wondering, you can find us on UT Austin, which is one of the best CS schools, and they also have this Java programming course, so it's CS 307. So if you guys want to read, Java's original name was Oak, and it was developed as part of the Green Project at Sun, which is like an old company in the 90s. I don't think many of you would remember it. So it started in the 90s by Patrick Nod, Mike Sheridan, and James Gosling, and it was hard to spend time to figure out what was the next wave of computing, because at that time they'd been using other older languages, and they just want to develop new languages that would, be more effective at, fixing nowadays problems. So it's going to be the convergence of digitally controlled consumer devices and computers. So you guys are wanting that Java is generally used for Android devices, and that's probably what they meant by that. Let's go back. Another important thing was applicant applications. So on the consumer end, being able to open applications, which is it's the job of the JRE, and we'll go over it later. But that was just that was another important thing. So many of the apps you might use if you have Android devices, many of the apps you might use, this is another purpose of that. Basically how Java works, right? So Java's platform independence is achieved by the Java virtual machine. It's something you need to download from Oracle. Essentially what it does is it goes through your code line by line, executes it. So this along with the JRE and the JDK, which provide the development tools, right? So to actually understand what your code is doing, if the computer understands what your code is doing, it needs those things. So a Java program consists of one or more files with a Java extension. So what happens is that when you save it, right, it becomes whatever the name of it is, Java, and then it gets sent to your compiler, and then it becomes a .class file, and then it gets run, and then obviously, it opens up on your computer. I discussed that here. So the .class file is Java bytecode. So this is like ones and zeros and stuff like that. Bytecode is like a machine language. It's just the most basic level of what a computer understands, and it gets sent to your processor and executed, basically. So to run a Java program, the bytecode in the .class file is fed to an interpreter, and that converts the bytecode to machine-specific code. So by machine-specific, has to do with how there's different systems like Mac and Linux and Windows. So that helps that. And then the interpreter is just a Java virtual machine, and you download that off Oracle. And the interpreter is platform specific, and what that means is kind of how the people that have created these different things like Linux, Windows, and Mac, they created different ways for their computers to see and run the code. So what you're going to do is when you go to Oracle and download the JDK, you can make sure that it's system specific, right? So 62-bit, 32-bit, or make sure it's for Mac OS and not like Windows. So yeah, say run any type of computer that has JVM running for it. So Linux, PC, Mac, Unix. So I'm using Mac, so they definitely have that. That's how it works, right? It works. So you write a Java program. This is probably the most basic one you're going to do, which is hello world, and it it gets saved as a .java file, and then it gets sent to your compiler, and then it becomes a .class file, and your interpreter, which is the JVM, goes through it line by line and reads it, sends it to the CPU, which runs it because it changed interpreter, which you download for your system specific, changes it what the system can read, right? So what Mac can read and what Solaris or Windows 32 can read. I don't know if any of you use Solaris, but mainly Windows and Mac, right? And as I said, it interpreters the JVM. One of the more important things about Java is it's a programming paradigm. By that I mean it's like object-oriented instead of logic-oriented. Object-oriented programming it has like inheritance and encapsulation, and it's just like levels of if you think of a feudal society, right? They have levels of power. Object-oriented programming is a similar thing, right? So you might have a superclass, and you might have lower classes and classes below that, and methods, and that's kind of what it means. And the most important thing is that simplicity is kind of like, it's really easy language to data language. And pure object-oriented program because it has encapsulation, inheritance, and polymorphism. So encapsulation, by that I mean so say you have an animal class, right? And in that animal class, you might have methods called get animal name, get animal food, get animal breed. That's just encapsulation, right? So if you go to your main class and extend to the animal class, you can also call those methods, right? But that's part of encapsulation. But you can't use those methods anywhere else because it's only in that one class. Another important thing is inheritance, right? So for those who were here before, I'm sorry about the echo. I'm in quite a big room actually, but I'll try my best to speak a little better. So the thing with inheritance, right? I don't know if any of you were here before from my Android Studio programming tutorial, but with inheritance, there's super classes, right? Which are basically the most basic level of classes. So you have like an animal class, right? As I said previously. No, an animal method, right? Set animal or something like that. Headphones. Yeah, I could try. Is this better? These are my headphones. I don't know if it's working now. So with inheritance, right? So if you have I was going over encapsulating or inheritance polymorphism. I think it was inheritance. Okay. So with inheritance, so you have a class, right? And you okay, so say you basically create an instance of a class which is called an object, right? So I have the animal class, right? But I create an animal object called cow, right? Because of inheritance, I can use all of the methods that are in animal class, right? So get feed, I can do cow that get feed. That's an example of inheritance because that method is in the animal class, but I can still use it in the main class where I have an instance of animal. Another important thing is polymorphism, right? So with that, say you have a method, you can override it, right? So say you have this method. Say you have get feed, right? So whatever the animal eats. So if you have your superclass, right, which is what your animal class, a basic response to that feed return grass, right? But if you want to specify it, you could override that method in another class, and you could say return, I don't know, chicken. It eats that, right? That's an example of polymorphism, right? Because you have the same methods, right? But in one class, you overrid it, so that means it can return something else. So all code can contain a class. You can't just have floating class in there. You can't have methods in the middle of nowhere. That means your code won't work. I'm sorry, I don't really know how to fix the echo. But with the no free functions, as I said previously, you can't have your code anywhere. There's no, you can't have methods just in the middle of nowhere. It has to be in the class. And the benefits of the programming paradigm, that just means how the logic is sorted out, right? So if it's just like, 1 second, I have my notes over here somewhere. So the benefits of having an object-oriented language like Java is that it has data security, right? So in each class, there's like a field, right? But that like field, like an integer or a character or a number, can only be used in that one class, right? You can't access it from another class, which is why that's so good for security. So if, say, like somebody, like an outside source, right? They want to, you got like an important, say you have like an integer, right? Or integer password or something. Somebody from the outside can't actually get it because it has that field can only be used in that specific class, right? And they can't access that class. Inheritance is also important with being able to use methods again and again and again without rewriting them. Code reusability is good too. As I said previously, inheritance helps with like not having to write code again and again. And flexibility and abstraction is important. So abstract is basically like you can have methods in a superclass, right? But you can override them in your own class and have them do something else that's specific to that class. Here. Okay, so here, simple Java program. Hopefully, I think most of you probably know this, right? Because it's kind of like whatever you do for any programming language, C++ or Python, and it just says hello world. So this is right here, this is the class and this is the method. And system.println is also actually a method, but it's one of the ones that you get like given to you as part of your JDK, right? So you can override this if you wanted to and make it return something else. So this is the class right here, and once you save it, it'll be put in a class called foo.java, and it's just basically a text file, right? It doesn't have it, it says that it is, and usually, if you're running a good program, it'll usually consist of many different classes. So, like, you can't, this hello world will not really be good enough if you wanted to, like, make an app for somebody. So, it usually have, like, different classes, right? So, for, like, if you were making, like, an app about a car or something like that, you might need one for, like, wheels or engine, something like that. Yeah. We're going to go over syntax errors, compile errors, content errors, and logic errors. So these compile errors are cut up to compile time. So whenever you convert it from whenever you have it written, right, you convert it to a .dot file, your compiler usually says something is wrong and will tell you. And usually that's pretty easy to figure out. You can just go to Stack Overflow and just like go over it. Runtime error. So errors and exceptions, another similar thing, right? You might have like a for loop, right, which is like going through an array, right, and it'll keep doing that forever and forever and forever if you don't stop it. And that's an example of a runtime error because it won't stop. And logic error is that like it compiles and runs, but it doesn't make sense once you actually use the program, and you might not notice it. And that's kind of one of the harder ones that you have to deal with. So there are different data types, primitives and classes, objects, right? So as I said previously, with classes and objects, right? So say you have an animal class, right? Public class animal, and then you have fields in it like name and date, and you have like a constructor. So like constructor, public cow, int age and string name. You can just take in these fields and then create like a version of a cow, a version of an animal that happens to be a cow, right? And when you create like an instance of a class, it's called an object, and that's also a data type because your machine can actually access that and get data out of it, like the name and the age. And primitives are the most basic type of thing, like ints, characters, strings, booleans, floats, and doubles. Another important thing is expressions and operators. So you can do a math in Java. I mean, you can do math in any language really, but they have plus. They have they have like ways to do plus addition, subtraction, division, and multiplication. And those are not the same way you would do it when you handwrite it. They have control structures, arrays, methods, and creating plus conditions. I'll go over that later. So one important thing is identifiers. So they can start with letters, digits, and underscores and dollar signs, but you usually wouldn't do that, and because it can confuse the runtime system. And usually it starts with a letter, and the variable method names are usually lowercase. They start lowercase with the internal words. Uppercase, which is called camel case, right? And constants are just can be written like that. And classes usually start with capital letters. Internal words are capitalized. So like this would be for classes, and it's usually to differentiate between different identifiers, right? So the identifier structure for a class would be different than the identifier structure for a method. So if we go back, this right here is an identifier, right? That's the class. So I said for classes, the first word always starts with the uppercase. So this identifier right here. This right here is an identifier. It's a method. And as I previously, this starts with camel case. So the first letter of the first word is always lowercase. Since there's only one word, it's just main lowercase. And yeah, moving on. So we'll start with the primitive data types. So you have the byte, the short, the int, the long, the float, double, boolean, and char. So mainly you only need to know char, boolean, double, float, int. But most of the time I was just using int and char. And along with that, I also use string, but string is like another type of char, right? So that's probably why you might do that. So you would stick with int for answers, like 1, 2, 3, and 4. You can't do negative numbers, unfortunately, so it's only above 0 and above. And double is for real numbers, so like 0.1, 0.2. And for float, it's kind of like a double, but it can only hold 67 decimal places, and it's usually used for, so like you're doing math, right? And you only need that many digits, that's when you would use the float. Boolean is obviously true or false, right? So if you want to say something's true or false, that would be it. And char is just for characters, right? So A, B, C, or D. And a string is a type of character, actually. So it's not one of the primitive data types. It's not one of the ones that dollar originally gives you. So a string could be like hello or goodbye, something like that. Moving on to classes and objects. So they're predefined or user-defined data types consisting of constructors, methods, and fields. Constants and fields may be primitive objects. So as I was saying previously, so you have like a public class animal, right? And then inside it you have fields such as int age and string name, and then you have your constructor, public animal, and then it has the inside like the brackets you have int age and int name. And then when you create it outside your class, you could just input that in, like say the age of your cow is, I don't know, 20, and the name of it was like beach or something like that, and you can create like an object of that. So essentially what these 8-bit and 16-bit, 8-bit means is that just shows how much data is allocated to it in your CPU. So by 8-bit, they mean 2 to the power of 8 to the power 16. So as you can see, as the bit gets higher, there's a bigger range of numbers, right? And it eventually gets to epsilon, which is pretty huge numbers. And floating point basically means that these numbers have decimal places in them. And Boolean, obviously true or false. Unicode is like A, B, C, D, zeros, and stuff like that. So whatever's like on your keyboard, basically. So a class is synonymous with like a data type, right? So you have your ints and your doubles, but you can name them, right? So you have an int A, right? So the variable A would be a type integer, right? And object is like a variable. So the variable, as I said, could be int a, right? A is a variable, and a is an object of class integer, and it's referred to as an instance of the class, right? So a is an instance of class integer. So what exactly do classes contain? So the classes contain the information details of the data type and information programmers who just want the data type. So for integers, right, this would be like adding, subtracting, and doing multiplication and division, and also concatenating it, right? So if you wanted to put together something else, it also has that. And objects are more complex variables because they usually have multiple pieces of internal data, like methods and how they run. And yeah, various behaviors carried out via methods, right? So get methods and set methods are just the most basic ones you might encounter. So creating and using objects, right? So rectangle R1. So you might have a class called public class rectangle, and in that you have a field, and inside that you have a constructor, right, which accepts things. It usually accepts variables, and then uses that to create an object. Obviously, if you had that, right, it would be rectangle R1 equals new rectangle something something, but this one doesn't have that, right? So it just creates a rectangle and uses the most basic type of, doesn't give it any fields or anything that's specific to it, right? So this is the creation of it. R1 new rectangle, this is the creation of another rectangle. And when you're creating them, right, you can either do it like this, declaring it and then specifying it, or you can shoot together. And this is how you basically call methods on the object, right? So you could do set size, and this is like this example, right? With Java, you can actually create 3D like images, right? And number 2D images, obviously, but it's basically setting the size of a dot, right? And another important thing is setting it to string. It's a very important method. But yeah, moving on from that. So Java has like lots of classes that you can use, and lots of like string, math, insert, character, double, system, array, scanner, file, object, random, and basically we're just gonna go over these and make you get like familiar with them. So basically, import is like import is reserved word because you can only use it for that one instance. So if you're importing something like array lists, right? So if you're programmed to actually use an array list or something like that, right, it has to import it. And what it means by reserved word is if you can't like go inside of your program and just use import anywhere you want, right? So you can't have a variable named import. You can't have integer import equals 3 because it will come as like a runtime error, right? So import can only be used there. So packages and classes can be imported to another class, right? So in this example, ArrayList is actually a class. It comes with methods. So usually, if you just mention ArrayList A equals, you just said ArrayList A, and you defined it, it wouldn't work because your program doesn't know what ArrayList is. It doesn't like know what to do with it. So that's why you need to import it. And AWT is usually references to like 2D objects, so you can like create stuff in a different window, and that can be like images or circles with colors and stuff like that. And usually these statements, the statements always go inside your class block, right? So if you were like here, right, they always go here, but you can never put them inside there because then they won't import. Because what happens is that when the computer is reading your code, right, it goes from the top to the bottom. So it needs to know that that is there first before it can actually run the code. So utils are just for like utility, it's for utility, but it includes whole packages. So this is actually a package, and or it can like list a given class. So Java util.random. So if we go back, this was a specific class inside that, but you can just define a whole package which includes different classes like array list. Well, they don't really, I mean, for if you CSA, you only really need to use array list. but there are other obviously things you can import. And what it does is it instructs the compiler within the package for types it can't define locally. So array list would be an example of that. And the Java language automatically imports to other classes. So that's like, queries and stuff like that. That's why you're able to use OpenValue.com, because it creates that already, because it imports that already for you. And it's not required to import classes that are part of the same project in Eclipse. Eclipse is like another system that you can use to develop code, right? Especially at JRE. Moving on, so string. So string is a standard Java class. So as I mentioned previously, it's based off of char. So char is actually char is a prototype, right? Also a class, but this class is based off of char. And it does a whole host of behaviors via methods. So system.out.println is also a method, and it's special because it's used so much, right? String literals exist, so another class of literals. So like you can say this equals that, and you can connect. You can do this with them. Concatenate. This basically means you can put them together, and it should be done with like a plus sign. So you could do Mike plus Scott, and that would become Mike Scott, and you can't really do that with integers, right? Because you can do that with integers and just add them. So another thing. So any kind of object on the other side of this operator, plus operator is object conversion string. So if you did if you did 1 plus 2, 1 add them, it should become 1 and 2, so it becomes 12. So if you wanted to print out something on your computer, you just do it system.out.print, and what that means by no new line. So if you do system.out.print A, system.out B, it would print A, B, and put them together, right? If you do system.out.print A, system.out.print ln B, it would go to the next line. So it would be A, next line B, and yeah, new line. So if you do system.println, this would be, these are obviously variables, so it would just be, so say if you define x as like 3 and y is 4, it'd be x is 3 and y is 4, and yeah. So constants are like, this is the way you specify values that are not computed and recomputed, but remain constant left the program. So true, false, none, C, C++, all these like prototypes, right? They usually stay the same. So to like name a constant, you'd use the keyword final, and what that means is that you can't change it outside of like your own program. So basically, you could do int final password, which means your password would never change. Even if somebody else like outside wanted to access it, they wouldn't be able to, and they wouldn't be able to change it anyways. Because of this, the scope may be local to the method or a class, right? Because you can only change it in there, and you can't change it anywhere else. It's final. So by convention, any numeric constant besides -1, 0, and 2 requires a minimum constant. So yeah. Reference operators. So this is the most basic one, right? It's going to be used to set equals, to set other variables equal to each other, or it can be used to like find out if they are equal to each other. And then there's also arithmetic operators. So this is plus, minus, multiply, divide, and remainder, right? So if you had 10 percent sign 3, the remainder would be 1. So this is just for integers, floating points, and arithmetic expressions. So assignment operators are basically just like, so say you wanted to add something to something else, right? You could do plus equals, minus equals, times equals, divide equals, right? So if you wanted to do 3 plus equals 4, you would add 3 to 4 and get 7. You could do increment and decrement operators. So it's like in a for loop, right? When you have starting integer, which is I, it could be 1. It's usually 0, obviously. right? And you have your upper, like wherever your like loop stops at, which could be like 30. Your for loop needs to have this plus or minus minus, right? Or else it won't go from 1 to 2 to 3 to 4, or 3 to 2 to 1 to 4. So avoid using inside expressions because right here, because then that can confuse the computer. And expressions are evaluated based on the presence of operators. So it looks at the operators first, and then looks at the numbers and sees what to do there. So Java will automatically convert numerical primitive data types. The results are not surprising. Usually, what this means is like if you wanted to add like an integer and double, it would create like a new variable that was automatically a double, because if you're adding an integer and double, the output has to be a double. You should also take care when missing integer and floating point numbers and expressions, because integers obviously have no decimals and floating points do. Sometimes that causes problems when you have to add an integer and a decimal. So meaning of an operator is turned by its operand. So this is usually like integer, but based on what it's acting upon, it calls a different method, right? So it could be either based on decimals or integers. So casting is a temporary conversion of a variable from its original data type to some other data type. If you're like being cast for like a part or playing a movie, and with primitive data types, if the cast is necessary from a less inclusive data type to a more inclusive data type, it is done automatically. So a less inclusive data type would be integer because it only has a set number of numbers, so 1, 2, 3, 4. But a more inclusive data type would be a double, because it includes decimals, right? So in text, this is like a less inclusive one, and this is a more inclusive. So this X, is when it's being put in. And so what this means, right? You can't have your B be an integer, and you can't have C be an integer, because that just won't work, right? Integers can only be converted to doubles, but doubles can be converted to integers, unless it is a way to do it, but it's just like it might cause runtime error. So if a cast is necessary from a more inclusive to a less inclusive data type, the cast is successfully by the programmer. So here, you're doing that. And this is what I mean that you can do it, right? So it's converting this double to integer. And that's what you can do to make it work. So as we were going over, outer ring is most inclusive data type, and the inner ring is least inclusive. I'm sorry about how it turned out, but I think it might have been a problem when I converted the PowerPoint to Google Doc. Google Slides. So expressions, less inclusive data types are usually converted to more inclusive, so integers to doubles. But if you try to place a more inclusive more inclusive variable into a less inclusive variable, you have to do it successfully, right, in the code, like right here, right? Because usually with that operation, the output would be a double, but you just make sure that it gets to the decimal point, and that's how it works. As you can see, double is the most inclusive, then it's float, long, integer, short, and so on. It's like, this byte is the most basic type of primitive type. Linear flow controls, these statements are executed in consecutive order. And what this means is that usually your program, the Java virtual machine, which is the interpreter, will usually go from line to line to line and read your code. It also has decision making with if-else statements. So if a certain thing is true, you execute this part. So if this might be confusing, right? What does Boolean expression exactly mean? This means if something is true, you would do this. If something is true, you would do this, this, and this. So single statement could be replaced by a statement block with braces. So what this means is if you have a if statement, right, and you only have one line under it, you don't need to use practice. But if you do, you need to use practice because usually your program will only look at this and just ignore these. If you want to look it all together, then you need to have practice. So Boolean expressions evaluate true or false. These are also important for if statements and things like, right? So operating different forms of logic, like doing one thing over the other, is important. So this is greater than, equal to, less than, equal to, equal, or not equal to, right? And if you want another case, right, for like more security, then you could do and, or just not. So and then is usually used for like if another case is true, or it's used like another case. And is like, let me say this again. If you have and, right, it means that for the code inside that block to execute, two things have to be true. If you have an or, and you have like two different types of things that might exist, only one of them has to be true for the code inside the block to actually execute. And this causes short circuit evaluation. These are done quickly. And which means if the first part of P and Q is false, then Q is not evaluated. Okay, so this, if P is false, then it doesn't work. But here, if P is true and Q is false, then it's evaluated. So an example could be this, right? So for this, wherever is in this, obviously, like, if it's like, so it's not print ln hello world, for that to actually print, x has to be less than or equal to x dot limit. Oh, and then, okay, so, and then or. So this means is that if, so say you have a block of code in here, right? And for that to run, this has to be true, and this has to be true. And what this is that x has to be less than or equal to x dot limit, and y has to be equal to less than or equal to y dot limit, right? But if it was this instead of this, then only one of these has to be true for that to actually run the code. There's more flow control, which is like if else's, right? So if Boolean expression was true, then it would run statement 1, else it would run statement 2. And you can do multiple selection, which means that you can have more more flows of control. So if, else if, or else. So logically it would look at this first, then this, and then finally this. So if none of these were true, it would just do statement 3. So individual statements can be replaced by a statement block like this, with set of braces of 0 or more statements. And Java also has a switch statement, but we'll go over that later. So we're not going to go over that right now, but if you wanted to, yeah, it's like that. It's the same way in Python, but Java statement is an easy way to do this, right? So for the switch statement, basically what happens is that it takes in like some sort of variable, and depending on if it equals something or not, then they'll speak different types of statements, right? It's very similar. Yeah, no problem. Another important thing is for loops. Basically, just execute some sort of statement for a set period of time or a set period of numbers. So any expression increases to be 0 or more, and they're separated by commas like this. So it can also be replaced by statement block, but it's just equal to a for loop. So, so for example, right, a for loop here, instead of being this any expression could be set to k.I equals 0, and Boolean expression could be until I is less than 3, and an increasing expression can be I plus plus. What that does is that it starts at 0 and it goes to 1, 2, and 3. And what that means is that it does the statement wherever is inside here 3 times because it increments. Another important thing is while loops. So usually this is like this basically runs while a statement is true. So So say like, like a statement, like wild animal exists, right? As I said, like with my example, wild animal exists statement could be animal.give feed, right? So that will give the animal, food as long as it's alive. And another way to do this is like a do while statement. So do statement while this is true. And the problem with that is like you could, say in like with an animal example, right? You could do cow.give feed, and then you check, and then the animal's dead, right? So you just executed that statement for no reason, which is why I recommend you do the while loop because it checks before you actually implement the statement. I can use this statement block if you want to. So break, continue, and other things actually stop this from running. So if you have a switch statement, right, and it's looking for things, break would stop running at all. And remember not to use break too much because if you use it too much and you don't know when you're using it, it will just break the whole program because it will stop other things also, which are necessary to actually run the program, which is bad. Know about this. Okay, arrays in Java. This just means like it's just another word for like a list, right? So arrays do contain numbers, they can be 2D and 2D. And usually they start at zero. And so they have built-in arrays, so you don't need to implement that. And array holds elements of the same type, so usually arrays can hold numbers, and by that I mean integers, so 1, 2, 3, and 4, or they can hold doubles. And so that usually is primitive data types or classes. So spaces for arrays can be dynamically allocated with a new operator, which is like the dot size. So here's an example of the arrays. So this is an array listed type integer. What this means is that there can be 10 elements in your new array list. So that would be, 10 numbers, 10 integers, for example. And this for loop starts from 0 and goes all the way to 10. So this code here is run 10 times. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it runs it this 10 times. And obviously I'm not going to solve this because it might take a while, but this is what it means. And right here, you'll see another example of how to deal with arrays. So this 3 is actually the third element of the array, right? So say you have 0, 1, 2, 3, right? It's counted like that. So the first element is usually 0. So whatever's in the third, whatever's the third element, right? But then our minds would be like the fourth number. That would be that. And similarly here, it's connected to the fourth element, but in our minds, the fifth number in the array list. In the array. Array is different. So all arrays will be dynamically allocated, which means that they just have to have whatever they're holding, declared. So integers or some of our classes have that could contain animals. And arrays have a quick final field called length. So if you want to find the length of your array, you do it like this. And you don't need the signs afterwards. And for arrays, this is a very similar type of thing, but it usually uses .size. So don't confuse length with elements in use. Elements start with an index of 0. Last index is length on -1. And so trying to access a non-existent element results in an array index of a bound exception. So if I go back, right, and I made this less than or equal to, that would give me an error of array index out of bounds exception because that would look for the 11th number, which is not in there. So that's why when you're reading a for loop, right? You cannot make it less than or equal to unless you start at 1. So array variables are object variables, but this just means that they can be integers, chars, strings. But as previously as my example, it could be objects, right? So an instance of a cow could be, an instance of an animal could be like a certain type of cow. and all values in the array are initialized. So by that, this just means like this is this is your array of integer type. So initialize means that we set equal to that, so 2, 3, 5, 7, or 10, 11, 13. This is fit for a double and fit for a string. So an native array of objects actually needs an array of other variables. So native just means that they're, usually it's already included with Java. So chars, strings, and stuff like that. And yeah, moving on from that. There's a type of array utility you can use on your array. So you can do a binary search, equals, fill, and sort. So these are just methods that, look at the numbers wherever you have in your array and sort them. So if you wanted to do like a sort for an array with numbers, it would sort them by lowest to highest. But there are overloaded versions for other type of methods. So strings, right? You can't. It's like hard to order them by any metric, right? Because they're not numbers. So there's definitely like if you did a dot sort on like an array with words, it would just use it based on like how many letters are in each word. And also there's another type of method there's a class called array copy. So it copies elements from one specified part array to another, and it can be used for arrays of prototypes and objects. And here's an example of it. The array copy. And basically what it does is it accepts whatever array you're calling, right? So in our example, it's called list. It's accepting whatever number you want to change, right? So in my case, that would be the first number that I see, so element 0, and then it'd be looking for like where you want to place that, right? So in my case, that would be a variable, or instead of a class and object, and then it would just put in a certain position, and then we do the length of the integer. So that's it here. So in this instance, my two arrays are list and temp, and I'm taking the first variable from list and putting it into the first variable of temp. And yeah. Another important thing is 2D arrays, right? If you can imagine like a table, that's what 2D arrays is like in terms of logic. So this is the number pair of square brackets indicate the dimensions of the array. So in this instance, there would be 3 numbers by 4 numbers, or in total 12 numbers. So like I mentioned, in a 2D array, the first number indicates the row, and second, the column. So there would be 3 rows and 4 columns. So Java multiple dimension arrays are handles differently, other languages, so like C++ and Python. Oh, my bad, this got messed up, but as you can see here, this is my two-dimensional array, right? It's similar to the one that we previously talked about, because there's 3 rows and 4 columns, right? But how Java, number sends it does it by the element, so it starts at 0. So that even though there's 3 rows, it's 0, 1, 2, and 0, 1, 2, 3, even though there's 4 columns. So if you want to set the set like certain number, something else, right? You could do math 2, 1, 12. So what this basically does is it goes down here, 2, row 2, and then column 1. So that would be set to 12. Obviously, you can't see that right now because it might have gotten messed up when I was copying it from my other computer. Okay. Let's skip over that. So multiple dimensional arrays are here. There's arrays of arrays. So essentially, like in our array of rows, which I think an array of rows basically. which means it can be a rag, so each row does not have to have the same number of columns, so I can change that. So ragged arrays are sometimes useful, which means you can change the size of the arrays, but usually we deal with rectangular matrices. So that just means like like a rectangle. So 3 columns by 4 columns. So each row has the same number of columns as every other row. And this usually is versus a precondition, so you can look at everything. And working on matrices normally requires nested loops. So what this means is nested loops. So for that you have to the outer for loop accesses the array by rows, and then the inner for loop accesses the specific row and looks at each column. That's why nested loops are used. Enhanced for loop, right? So this is useful for shorthand accessing all elements in an array, and it's alternating. It's in the I++ and the for the length you could just do this, and you would do I equals something, and then they'll just run through it like do that. And here's an example of it, right? So here is the old way of doing it, right? Which is a usual for loop. Starts with I, keep on going to the list length, and keep on incrementing, and keep on doing this, and printing this. And with the new version, it starts with val and goes to list. So val is usually going to be 0 in this instance, and list would be the list length. So if the list length is 10, right? It would do this 10 times the system. So it's the same as this. So methods are just basically like analogous to procedures and functions in other languages. So set something, get something. Those are basically methods that you would use. And in that there are local variables, parameters, and instance variables. So local variables are something you can only use in a certain class. So I don't know. It's just means like with the scope, you can with Java there's a thing called scope, right? So you can't access variables outside a certain class. So that's local variables. Parameter is another important thing. So usually your method will accept some sort of parameter, right? So if you're using .set name as a method, right, you would have a parameter that you put in that. So .set name Bob, right? And you had cow.set name Bob. What that would do is the parameter is Bob, but that was the name of the cow to Bob. And another important thing is instance variables, which means they only exist for a certain amount of time. That's usually when the program is initiated, or that's usually when it exists, right? So an instance variable could be instance variable that says an instance of a class. So in my previous example, the cow was an instance of the cow class. So cow, C or something, whatever his name is a instance variable. And if you feel comfortable with the variable scope, so where's the variable defined, right? So for my cow, right, I can only do functions on it in that certain class, right? So I can't go to my main class and call cow. And that's why it's important. Methods are specified the means by which objects are manipulated or changed. So as I said previously, setting the name or changing the size of something, that's what they mean. So the method header usually consists of the access modifiers, so public, package, private, or private. So these are the most important ones, right? So public means you can access them to other classes. Private means you can only access them in that certain class. Static keywords usually is optional, but you don't really need to, you need to think about that. Another important thing is return type, so it could be void or integer string. So what they mean by void is, right? So if you have public, so if you have a set method, right? Set name, it would be public void set name something that have parameters, right? But it doesn't return anything to the user. It'd be void, right? It does whatever you want on its own. Now the opposite would be, get name, right? The return type for that would be a string because you want the name of it, and that's the string. And the parameter signature, right? So for that, as same as my example, it gets set name, right? So public void set name int a. So the parameter signature will be int a. That means that the method would like accept an integer and do logic on that. Some more methods. Local variables can be declared within methods, but you can't use them outside the method because of the scope. So that's usually used for like temporary variables you only use when you're executing certain piece of logic, right? Methods can contain statements, so if they want to do something else, go execute another statement, go execute another method. They can do that. Methods can call other methods, and yeah. So I'll show you how to stack methods. So the main method is where a standalone Java program no longer does an execution. So if you're using IntelliJ or anything or any IDE, that's usually where you would make the most basic program. So a common component are trying to call a non-static method to a static one. So public class static. So this is a static void. And if you try to call method one, you can do that. If you try to call method two, you can't do that because it's not static, right? So just keep that in mind. And obviously they're in the same class, right? So these methods are in public class, for example. Method overloading and return. So method overloading is part of polymorphism, which basically means that methods can do different types of jobs, right? Depending on if you override them. So say I have as I said previously, my get feed example, that's a method right there, right? So usually we return grass as, because usually what animals eat, right? But if you override it in a certain class, you could say that get feed returns hay. And that's overloading it because that's returns something else. So a class can have multiple methods with the same name, but the parameter signature is unique. And it just means that whatever accepts is different and whatever returns is different, right? So it can return integers, strings, or characters. And actually, you can't do that. Only what it actually asks for is important. So what I mean by that is with these methods, right? What it means by parameter is unique. It's like so say you have three methods, right? But they all take in strings. If they all return strings and all take in strings, the way that you can differentiate between them if they have the same name is how many strings they take in, right? So one method can take in one string, one method can take in two strings, one method can take in three strings. So even though they have the same name, they're different methods because they take in different parameters. But you cannot change the parameter type, the return type, right? So you can't have public void, some name, public string, and some name, So methods in different classes may have the same name signature, which means their return type and their name. But you don't need to overload the method because those methods will only be used in the scope of that class. So you're probably not able to differentiate between them and not get confused. So if method has a return value other than void, must have a return statement with a variable or for some public type. Note that means that if you have a public string get feed, right, you need to have return graphs and quotation marks, right? Because it's asking you for you to return a string. And if you don't, then let's throw it on a crash, right? But if you have void, then it's not do anything like that. So multiple return statements can be allowed, and whatever it's could be like what they mean by return statements is like I said previously with if else statements, right? If else statements. So a certain case could be true, and it could execute that return statement. Another case could be true, that method, and it execute that return statement. So that's what they mean by return methods, right? It's means you can't call for returns, but you can have them written down physically there, and it won't crash the code if you make sure that only lines actually run. So a method may have any number of parameters. So each parameter is listed separately. What that means is separated with a comma, right? You need to look at this, but final can be applied, but because you can't change it, and all parameters are passed by value. go over it later. So a value parameter usually needs a copy of the argument that is sent. So like an integer, right? And that method, they would create a copy of that and they would use that. So the changes to the parameter do not affect the argument. So and then on the other hand, our reference parameter is another name for the argument is sent. And so changes to the parameter are really changed to the argument and thus are permanent. So here's an example of value as reference, right? And references are usually used in C++. Void value in text, x plus 10. So if you were to call that, then they would change that. Would change both them, but in reference it would change. And reference it only changes one. In value it only changes one. In reference it changes two. But you don't even know that because that's not on the APS CSA exam. So methods should include preconditions and postconditions. So these are what things that must be true before a method is called. So postconditions are things that will be true after a method is called. So the conditions were met. So it's responsible for the method to ensure the conditions are met. So you'll want to know this actually. Okay, so going on. So JavaBot is basically a program that takes comments in Java source code and creates the HTML documentation pages, right? So obviously for me, like Android Studio, right? They have a Java doc, and that explains all the methods and the classes, and it's easier to understand that. And then it explains so much for that for Java, right? Which goes over all the classes that are in the JRE, DBK, and also how the JVM works, right? And how to download all that stuff. So this is the basic formula of how they explain things. So they list the preconditions and the postconditions, the parameters, and what it returns, right? And then they go on to what the actual method looks like. Let's see, I think we're done actually. Okay, it seems we're done actually. For all of you wondering that why we didn't go over the programming by contact, it's because that's not important. And when I took APCSA, we never learned about this. This is not really important for you guys to learn. Other than that, if you guys want to see this exact presentation, it's actually listed on the UT Austin CS webpage. So if you just search up UT Austin Java, you can find it. This is a CS 307 course, which means it's more advanced, but you can still run it. And this section we went over, which is like one of the basic ones that they have. So it's more like a multi-pronged section, multi-pronged program. So we only went over one section. That's fine. Other than that, thank you all for coming. Looks like we had a lot of people come, and hopefully my questions were good. And goodbye, everybody. Guys, can actually leave if you want right now.